Okay, problem 56. First we have these two tanks, 1 and 2. They have a large opening at the top. They have a small hole in the side. The cross section of that hole on tank 2 is twice that of tank 1. Our tank 1 has half the hole size as tank 2. So they ask, what is the ratio, not the ration, ratio of the density in tank 1 fluid in tank 1 to the density of fluid in tank 2. All right, so let's look at part A. So first we have that the what is density if the mass flow rate is the same for the two holes, right? So the flow rate for the mass flow rate is rho 1 times A1, the area of the hole, times velocity of the water or the fluid exiting that hole. All right, and so that gives us rho 2 A2 V2, and we know that A1 equals 1/2 A2, right? And so we can write this as rho 1 times 1/2 A2 V1 equals rho 2 A2 V2, right? And the A2 drops out. I'm going to divide by V1. I'm going to divide by rho 2, and I get rho 1 divided by rho 2 is twice, all right, V2 divided by V1. Okay, now you're like, all right, what does that mean? Well, if you turn to example, the example on page 404, example problem 1407, there they cover how to sort this out. So the pressure at the top on 1 plus 1/2, right, rho 1 times its velocity at the top squared plus rho 1 times g times the height above the hole equals, all right, so now with a pressure, all right, at the top, so the external pressure at the top, all right, is the same because we have a hole, right, so it's the same as it was before, and now we have again rho 1, and now we have v squared coming out of the hole plus rho 1 g, and now h down here is 0, right? Okay, so the key point they have here, if this tank is very, very large, or large relative to the size of the hole, then the velocity at the top is going to be very, very small compared to the velocity coming out of the hole at the side. So we're just going to ignore this term, right? Just going to ignore it. This and this cancel out. That's 0. And so we get down to the velocity of the, call it V1, the velocity of the fluid coming out of the hole is 2gh. All right. Now you notice this is independent of the density of the fluid and only depends on the height. And so for both tank 1 and tank 2, we start off at the same height. These velocities are the same. And so what we get out of this is that rho 1 over rho 2 is 2. So rho 1, the fluid in tank 1, is about twice as dense as the fluid in tank 2. All right. Part B, what is the ratio of the volume flow rates of the two tanks? Okay, so the mass flow rate is rho AV. The volume flow rate is just AV. All right, let me start with putting in part B. So RV1 is A1 V1, and RV2, what notation does the book use? RV1, RV2, okay. RV2 is A2 V2, and we want the ratio RV1 divided by RV2, and so A1 V1 over A2 V2, oh, A2 V2. Now, we just went through A1 and V1 are the same, A1 over A2. So this is 1/2. Remember, A1 is 1/2 of A2, right? Divided by A2. And so that tells us the volume flow rate is 1/2. Relative volume flow rate of V1 to V2, RV1, RV2 is 1/2. Okay, part C. Part C is, at one instant, the liquid in tank 1 is 12 centimeters above the hole. If the tanks are have equal volume flow rates, what height must the hole in tank 2 be just then? Okay, tank 1, all right, it depends only on height, and we need this. Basically, we want what, when it's tank 1 is 12 centimeters, tank or have equal volume flow rates, what height above the hole must liquid in tank 2 be just then? In other words, if we want this to be 1, all right, if we want this to be 1, then we need for V1 divided by V2 to be 2. If V1 divided by D2, since we're no longer at the same height, right? When we're at the same height, they're equal. When we're at different heights, they are not equal. We need V1 divided by V2 to be equal. So H1, right, divided by 2GH2. We want that. All right. So everything cancels out except for H1 over H2. All right. I'm going to square things so that we have 4 is H1 over H2. We know that H1 is 12 centimeters. Let me take some dead space out because I don't really need to we need one more line. We know that H2 then is 1/4 H1, right? H1 is 12 centimeters. So H2 equals, at this point, 1/4 H1, which is going to be 1/4 of 12 centimeters, which is 3 centimeters. And that's it for this problem. Clean up a little bit and get it onto one page, and there you go. H2 in part C is 3 centimeters. That's it for problem 56.